This is a smart TV remote. It has very few buttons and I know exactly what each button does. Now take a look at this remote. This is a very old remote of a TV that is not even smart, and I probably know about just 10% of the buttons. Now this is an example of a bloated interface, and in this video we're going to talk about how to avoid such interfaces. I wonder what this red button does though. Maybe it will make you a subscriber. Hello engineers, welcome back. In this video, we're going to talk about the fourth principle in Solid, which is Interface Segregation Principle. I hope you're ready. Let's get started. So, as per the definition, no client should be forced to depend on methods it does not use. But how can someone force a client to do anything? In order to force something in the programming world, we use the concept of interfaces. Interfaces are nothing but contracts. It is a set of rules. Anybody using that interface should follow all the rules in that contract, right? So let's try to understand this with an example. So let's say we have in a hypothetical city where on one side we have a rich neighborhood and on the other side we have not so rich neighborhood, but both of them have signed a contract about their maintenance fees in order to live in the neighborhood. So anybody who is living in the rich neighborhood or the poor neighborhood will have to pay the same amount of tax or the maintenance fees. Now, people on the left side will not have much to complain because they are getting all the nice amenities and the facilities in the neighborhood, but the poor neighborhood is not getting any of those facilities. The roads are not nice, there are wires everywhere and so on. So obviously they are unhappy, but they are being forced to sign a contract in order to live here, and they have to pay all the amount that the rich neighborhood guys are paying. So this is an example of a client being forced to sign a contract, but is not even getting all the benefits. They're not getting all the facilities from the richer neighborhood, but they're still having to pay all the taxes and maintenance fees. So this is a violation of the interface segregation principle. No client should be forced to depend on methods it does not use. Now, I know this is a hypothetical situation, but it gives you some context into how this interface segregation principle is thought about, right? So we'll take a look at some code examples to make this even more clear. Okay, let's go to VS Code. So we have a new folder now, Interface Segregation Principle, and as always, we have two files, concept.cpp, usecase.cpp. In the concept file, we will try to understand this with a fun example. In the use case file, we will try to understand this with a real world example, right? So let's say we are a robot firmware manufacturing company and we have created a nice firmware which does clean, cook and dance. And we are shipping this robot interface firmware, and anybody who is willing to use our firmware will have to implement all these three methods. Let's say a manufacturer is trying to build a cleaning robot and has no choice but to use our robot interface firmware. But his intention is to just build a cleaning robot which does a cleaning operation, but still he has to implement the cook or dance methods which are not relevant to his use case, but still being forced to do so because he signed a contract with us with our robot interface firmware. So this is an example of a bloated interface where it puts everything into one interface and forcing everybody else to implement everything from the interface. So this is a violation of the interface segregation principle. So when I run this code, you see that it is happily able to clean the house, but it does not know how to cook, it does not know how to dance. But still these methods are implemented and this is a violation. So how do we fix it? Let's have a look. Now, as a firmware manufacturer, instead of creating one interface called robot interface, I'm going to create three interfaces. One is a cleaning robot interface, another is a cooking robot interface, and the third one is a dancing robot interface. Now, whoever is trying to use my firmware will now have a choice whether they can use a cleaning one or a dancing one or a cooking one. If they want, they can also combine a robot which does both cleaning and dancing, or cooking and dancing, or dancing and cleaning, and things like that. But for now, let's take a look at this example. We are building the same cleaning robot which does cleaning robot interface contract instead of the main interface contract which was doing everything. Now this is a cleaner implementation. We just have one method called clean, and we just have one method called clean that we can call upon, and cleaner.cook, cleaner.dance will not compile because this interface does not have those methods, and this is what we need. This is a more flexible design and more flexible implementation. We can sell three products now as three separate interfaces instead of just one product, which was causing a trouble for everybody, right? So when I run this code, see, it is happily cleaning the house and no problems there. Now let's take a look at the real world use case. First, let's take a look at the violated example. Let's say we have a printer interface. We are trying to build a printer firmware. And we put in three things here: print, scan, and fax. And let's say we are the only manufacturer of this printer firmware. So let's say somebody is trying to build an inkjet printer, which does both printing and scanning, but it does not know how to do a fax. But because it is implementing our printer interface firmware, it is being forced to implement a fax method, which is a violation of our principle. So when I run this file, we get printing using inkjet, scanning using inkjet, but I don't support faxing, but it is being forced to implement this method. So how do we fix it? So you might have guessed already, we create different interfaces for each of the functionality. So instead of creating one printer interface, we now have three different interfaces, one for printable, one for scannable, and one for faxable. And whoever is creating an inkjet printer can now take upon printable and scannable and avoid the faxable. And this inkjet printer can now implement only two methods, print and fax, and happily do printing and scanning. And if we do printer.fax, this won't compile, which is correct. So if I run this code again, we get printing using inkjet, scanning using inkjet, which is exactly what we need. So this is a good example of an implementation that follows interface segregation principle. So I hope you have understood the concept and the idea behind interface segregation principle. If you have any questions or suggestions, definitely put them in the comments below and I will address them for you. Thank you so much for watching, guys. In the next video, we will tackle the fifth principle in Solid, which is the dependency inversion principle. I will see you there. If you haven't subscribed already, do consider subscribing. Thank you so much for watching. I will see you in the next one. Cheers.